Imagine looking up at the stars and feeling the same resonance that has fascinated humanity for thousands of years. Ancient peoples charted their paths in the sky, believing that the sky was the key to their destiny. Nowadays, astronomers are pushing the boundaries of our knowledge and using advanced technologies to answer questions that have puzzled mankind for centuries. What lies beyond the stars? Are we alone in the world? With the launch of the James Webb Space Telescope, JWST, we have begun a journey that will lead us to answers to these profound questions. This telescope is unlike anything we've ever seen. It promises to redefine everything we know about space and reveal secrets that have been hidden for years. But with each answer, new questions arise. Can we get closer to the greatest revelations in human history? This is not a new part of the planet. This is the beginning of a new era in understanding our world. The stars have always fascinated people, from ancient peoples charting their positions in the night sky, to modern astronomers using advanced technology to exploring the edges of the world. Our desire to understand the world has driven scientific discovery for centuries, pushing people to push the boundaries of discovery beyond what was thought possible. Today, thanks to the James Webb Space Telescope, JWST, a mechanical marvel that is beginning to rewrite the history of our universe, we are on the verge of a major breakthrough in understanding the universe. JWST was launched in December 2021 and the results of the mission are already impressive. Not only has he exceeded expectations, he has begun to challenge our deepest beliefs about the world. From the formation of galaxies and stars to the potential discovery of extraterrestrial life, the telescope's unprecedented capabilities promise to transform our understanding of the universe. But the JWST's revelations aren't just expanding our knowledge, they're also raising profound new questions about the origins of galaxies, the existence of life beyond Earth, and the very nature of the universe itself. Before diving into the earth-shattering discoveries that have already been made, it's important to appreciate the sheer magnitude of the JWST project and the countless achievements that have made it possible. The telescope is the result of more than 2 decades of tireless work by a team of dedicated scientists and engineers who were determined to create an instrument that could surpass even the legendary Hubble Space Telescope. The origins of the JWST can be traced back to the 1990s, when NASA and the European Space Agency, ESA, first began discussing the possibility of a next-generation space telescope. Their vision was simple yet incredibly ambitious: to build a telescope capable of looking back in time to the birth of the first stars and galaxies, while also scanning the atmospheres of distant exoplanets for signs of life. This concept would not only require significant advancements in technology but also unprecedented innovation in the fields of infrared astronomy, mirror design, and thermal management. Unlike the Hubble Space Telescope, which observes the universe primarily in visible light, the JWST was optimized for infrared observations. This distinction is crucial because many of the most distant objects in the universe emit light that has been stretched by the expansion of the cosmos into the infrared part of the electromagnetic spectrum. Known as redshifted light, this faint glow from the earliest epochs of the universe is invisible to the human eye and can only be detected by instruments like the JWST, which are designed specifically to observe in infrared wavelengths. One of JWST's most notable features is the large segment mirror, which has 18 hexagonal segments that work together to create a 20-foot wide screen. This is significantly larger than Hubble's 2.4-meter telescope, allowing JWST to gather more light and observe objects fainter and farther away than anything Hubble can see. These components are made of highly transparent beryllium and coated with a thin layer of gold to increase reflectance in infrared light. However, reflection is only part of the telescope's amazing design. Another important component is JWST's shield, a 5-layered structure about the size of a tennis court that protects the telescope's instruments from the sun's heat. This shield allows the telescope to operate at extremely low temperatures, which is essential for detecting faint infrared signals coming from distant galaxies. Building such a complex and sensitive instrument posed many challenges, and JWST's development was plagued by delays and budget constraints. However, after more than 2 decades of hard work, the telescope will be launched on an Ariane 5 rocket from French Guiana in December 2021. Its destination is a place in the area called the Second Lagrange Point, L2, which is 1.5 million kilometers away. The Earth in this area, the powers of the Earth and the Sun are balanced, so that the binoculars are in good condition, to remain in the shadow of the Earth, and not interfere with the radiation of the Sun. Implementing JWST is a risky endeavor with more than 300 areas of vulnerability. One of them was killed during the entire mission, but as a testament to the skill and dedication of the team behind the telescope, the mission was successfully completed. JWST's mirrors and sunroof opened as planned, marking the successful start of a new era of space exploration. One of JWST's primary goals is to explore the universe just a few hundred million years after the Big Bang. The telescope's powerful infrared sensors allow it to peer through the dust and gas that obscures distant galaxies, giving scientists an unprecedented view of the early universe. In February 2023, JWST made one of its most exciting discoveries to date, the discovery of 6 massive galaxies that existed between 500 and 700 million years after the Big Bang. This discovery changed our previous models of galaxy formation. According to the prevailing theory, galaxies were small and simple in the early universe and grew larger over billions of years by merging with other galaxies. However, the galaxies found by JWST are large and appear to be relatively small. This suggests that galaxies form much faster than previously thought, forcing us to rethink our understanding of the early universe. While JWST is revolutionizing our understanding of the early universe, JWST is also playing an important role in the search for life from Earth. One of the telescope's primary objectives is to study the atmospheres of exoplanets, planets orbiting stars outside our solar system, in order to determine whether they might be capable of supporting life. By analyzing the light that passes through an exoplanet's atmosphere as it transits in front of its star, scientists can determine the composition of the atmosphere and look for the presence of molecules like water vapor, carbon dioxide, and methane, substances that could indicate the potential for life. In September 2021, just months after its launch, the JWST captured its first direct image of an exoplanet, HIP 65426b, a gas giant located about 385 light-years from Earth. While this planet is unlikely to harbor life, the image demonstrated the telescope's unprecedented ability to directly observe exoplanets, something that had never been done before. This breakthrough opens the door to studying a wider variety of exoplanets, including smaller, rocky planets that could potentially support life. One of the main targets for JWST is the TRAPPIST-1 system, which consists of 7 Earth-sized planets orbiting a red dwarf star 40 light-years away. 3 of these planets are in the habitable zone of the star, the area suitable for liquid water. JWST is studying the atmospheres of these planets and looking for signs of habitability. Although it is still too early to draw definitive conclusions, the data collected by the telescope could reveal the first signs of life outside the solar system. While the James Webb Space Telescope is redefining our understanding of the universe, its ability to probe the universe's dust and atmosphere is essential to reveal the hidden structures of ancient galaxies. By capturing the light that took billions of years to reach us, JWST acts as a time machine, allowing scientists to peer into the early stages of the universe. One of Earth's most exciting discoveries is the discovery of 6 giant galaxies that formed just 500 to 700 million years after the Big Bang. These massive galaxies, which are larger and more complex than previously thought, have challenged models of galaxy formation. In the past, galaxies were thought to have been small in the early universe and grew over time by merging. But the JWST observations show that some galaxies formed and grew rapidly, changing our understanding of the universe. This discovery not only changes our understanding of galactic evolution, but also raises new questions about the role of dark matter and dark energy in shaping the universe. As we move further into consciousness, the JWST project is beginning. Over the next few years, this amazing telescope will continue to push the boundaries of space exploration and unlock the mysteries of the impossible. From studying the atmospheres of distant exoplanets in hopes of finding life to exploring the nature of dark matter and dark energy, JWST is at the forefront of a new era of astronomy. The contributions are far-reaching, not just for researchers, but for the broader human understanding of our place in the universe. With each new discovery, JWST moves closer to answering some of science's most profound questions, reminding us that the universe is far more complex, mysterious, and fascinating than we thought.